Hi there, folks. Today we're looking at measures of center. And if you remember this from previous years, you probably talked about it in terms of measures of central tendency. Measures of center are essentially the same thing, except we're only going to look at the mean and the median. We won't deal with or worry about mode anymore. Okay. So the mean, we have a couple special ways that we designate some of these things. It's still the same formula. It's still add up all the data values and divide by how many data values you have. We just express it this way. So this X bar, X with a bar over it, that is the symbol for a sample mean. If I could write, let me try that again. So anytime we see the X with the bar over it, it means sample mean. This symbol right here, that's uppercase sigma. That means the sum of. So sum of. Okay, so and that's the sum of X, which represents all the data values. And again, this is what we've always done with mean. It's the sum of all the data values. In statistics, we just kind of have our own way of representing these things, and so just getting used to some of these symbols might take a little while. But X with the bar over it, always the sample mean. That sigma symbol is always means we're adding things together, and then X represents the individual data values, and then this guy right here, N. That's the number of data values we have, and that's always the sample size is what we call it. And when we say sample size, the sample size is always how many data values we have, okay? Those are one and the same, all right? We'll have other symbols later when we talk about the mean. I'll put this off to the side here just so you kind of see it. But population mean, if we're talking about the mean of an entire population, which we don't have to worry about this now. You don't even have to write this down now. We use this symbol mu. It looks kind of like a messed up M or a messed up U, but it's mu. And we use that when we talk about population mean, and we'll see that later in the course, okay? So again, this is the same thing that we've always done in terms of finding mean. We just have an official formula for it now. Sum of the data values divided by the sample size, okay? And we denote that, we label the sample mean using that X bar, the X with the bar over it, okay? The mean is typically the best measure of center if we're talking about symmetrical data or if the data is slightly skewed, okay? So if we're borderline symmetrical, we want to talk about it in terms of the mean. That's the best measure of center, okay? The median is the middle data value in the set. So we line them all up and then find the one that's in the center. And remember, if there's a tie between the two, you have to find the average, what's in the middle of those two data values, okay? So if two values are tied for the center, you have to find the data value that's halfway in between those two. And you can always do that by adding them up and dividing by 2. We've got a special little formula here, and you don't have to use this. You can just count and start crossing off from each end like you've done in the past. But if you do n plus 1 divided by 2, that'll tell you the location of the median. All right. So if I do n plus 1 divided by 2, the sample size plus 1 divided by 2, and it gives me a 13, it just means I have to count to the 13th data value, and whatever that value is will be my median. Okay. If that little formula gives us a decimal, something like 9.5, it means that my median is whatever data value is halfway in between the 9th and the 10th data value, okay? So if it's 9.5, it's the location of this thing. I have to find the 9th and the 10th data value and find the median by looking in between those two, okay? And again, the median is the best measure of center when the data is obviously skewed, so clearly skewed right or clearly skewed left. In the past, we've talked about this in terms of it's best when there's an outlier, okay? So if there's an outlier, and, that goes hand in hand with this idea of skewing. If there's an outlier, it's probably going to cause this data to be skewed in some way, is typically what happens, okay? So when there's an outlier, the median tends to be the best measure of center. That's because we're talking about skewed data. So we're kind of taking this up a notch when we talk about statistics and saying, you know what, median is best when things are skewed, all right? For example, if I want to graph this data set, I'm going to graph it and then discuss the data in terms of SOCs, and then I'm going to calculate the measure of center for this thing. Okay, so I'm going to calculate the mean, I'm going to calculate the median. All right, and so for this one, because the data is pretty spread out here, when I look at this thing, we've got 98 all the way up to 325. I'm just going to do a histogram for this one. So let me set up my histogram. I'm going to need my heights over here. And then I'll need my frequency over here, the count of these things. And I'm going to start, our lowest value is 98. So I'm just going to go to make it easy on myself. I'm going to go 90 to like 130. And the next one would be 130 to 170. And so on and so forth. And remember, when we're doing these, we want between 5 and 10 groupings here. And so this does it for me. It gives me 6 groupings, which is fine. And then I just start counting up from 90 to 130. And remember, that means 90 to less than 130. So I don't count the 130 here. I don't count that until the next group. Looks like there's 4 of those. From 130 to 170, it looks like there's 1. From 170 to 210, it looks like there are 4. And again, we don't count the 210. That'll get counted in the next group. So then from 210 to 250, looks like 5. And again, that 210, because there actually was a 210 value, it doesn't get counted in the 170 to less than 210 group, gets counted in that second group. All right. That's one of those things that students tend to make mistakes on. 250 to 290, there aren't any. And then the 290 to 330, there's quite a few. It's 5. Okay. And so now I'm just going to graph this thing. Setting this guy up. And again, when you're doing a histogram, you can just kind of start this at 90 right here. And then just count up like you would on a number line. 130, 170, 210, 250, 290, and 330. Okay. And then over here, we're just counting, let's see, 1, 2, 3, 4, 5, 6. We can just go by ones here. And I start setting up my bars. My first bar goes from the 90 to the 130, and it should have a height of 4, because that's the frequency. The next one has a height of 1. The next one also has a height of 4. Next one has a height of 5. Next one, sorry, that's an ugly looking top there. There we go. Has a height of 0. I'll just draw a little line here. And then we've got a height of 5 again. And when we look at this data set again, I'll do a little bit of just a quick version of shading just so we can kind of see this thing a little bit better. Just makes this a little easier on the eyes, a little easier to look at and be able to discern some things. And so when we look at this thing, like if I'm describing in terms of socks, this thing almost looks uniform. It's pretty close, like other with the exception of this guy. So if I were to kind of draw something around this, yeah, I might say that it dips down there or even here. But it's almost fairly symmetrical. It could dip that way down into those valleys. So when I look at this thing and describe the shape of it, I would say that the shape, I could maybe call this thing bimodal or something like that. It might be bimodal, depending on your view of this thing. I would probably say that it's also fairly symmetrical. When we look at this, we have like a high spot on each end. There's a high spot in the middle. There's a dip in between each of those. So again, fairly symmetrical on each side. The outliers, even though there's a gap here, I probably wouldn't consider all of these values outliers just because there's so many of them piled up there and it's pretty consistent with what happened on the other end. So I wouldn't necessarily consider those outliers since it's one of my peaks. All right. If it was like 1 or 2 values that were separated there, I'd consider them outliers. But I'm going to say here that there appear to be no outliers. And then the center of this thing, Just doing an approximation here. I might say the center is anywhere in that, kind of 210 to um, 250 range. And so I might just kind of slap it right in the middle of that and say, it's 200. Sorry, if I could speak, 230, something like that. So I'd just say around 230. And then the spread. I could look at the actual like data that's listed off to the side over there and say, oh, it goes from 98 to 325. Or just for my graph, I'd say it goes from around. Sorry, I just saw my typo in there. Around 90 to 330. Okay, just based on the graph. And so this kind of gives me an idea what this data looks like. Now, if I wanted to calculate the mean and the median, well, the mean this time, I have to add all these data values up. So if I add all these guys together, and I'm going to have to scroll up here a little bit, I would just take this off to the side and we'll just do this on our calculators. When I add all those up on my calculator, I get 4,192. I won't bore you with showing me punching that into the calculator, so I just jumped ahead. And so that's the sum. So when we talk about the sum of this thing, all the data values add up to the 4,192, divided by the total number of data values this time. This time there are 20 data values in this set if we go and count them all up, so that's 20. And if I plug that into the calculator, I get somewhere around 209.6. So that's my mean. And when I look at the median then, I could do the little formula for the location of this thing. The location would be n plus 1 divided by 2. So that's 20 plus 1 divided by 2. And so that's 10.5. And essentially what that's telling me is that's the location of this thing. So rather than sitting here and like, a lot of times when we did this in the past, you would probably like start crossing off from each end. I cross that one off and this one off, and then you keep going. The problem with that is now I can't read my data values and it makes a mess. By doing the 10.5 thing, I just have to count and go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's the 10th data value and the 11th data value. It means that the median should be at the 10.5 location. It should be exactly halfway in between those two, which is 207.5. Okay. And so that's the idea. Rather than having to do all these crossing off type things, I can simply find its location using that little formula. Okay. So 207.5. There's nothing wrong with using the old cross off from each end method. That would be fine. And now when we can kind of compare these things, let's see, this was 209.6 and the 207.5. They're relatively the same, okay? So when we look at those two values, they're pretty close to one another, which is why I might look at this and say, the mean is a pretty good representation. The median isn't really that much different. And so I wouldn't be able to say that the median is really any better for this. And again, that goes back to this idea that, oh, this is fairly symmetrical data. So of course the mean is going to be probably the better representation, okay? One of the other things that we can do with this then, when we talk about the idea of, the mean and the median and how those things are affected by the idea of skewing, again, symmetrical, the mean is pretty good. That's because the mean and the median are pretty much the same when we're talking about symmetrical data, okay? The reason we would want to use the median as the better representation when things are skewed right or skewed left is because the mean is more affected by skewing. So when something is skewed to the right, the mean is more skewed to the right than the median would be, okay? And so when things are skewed to the left, the mean is going to be more skewed to the left than the median would be, okay? So there's a greater effect on the mean when we're talking about the data being skewed, and that's why we tend to trust the median more, all right? But that also allows us to predict whether the data is going to be skewed right, left, or symmetrical based on these values. So right here, when the mean and the median, this symbol right here, that means approximately. When they're approximately the same like they were in the previous example, we would say that the data is symmetrical. And again, going back to that previous example, yeah, look at these. These are approximately the same. And so if these are approximately the same, I would have predicted that this data is symmetrical, and that's what we decided when we looked at the graph anyway, okay? If the mean is greater than the median, in other words, the mean is farther to the right than the median is, well, then the data is probably going to be skewed to the right. Because again, the mean is more affected by skewing than the median is, okay? When the data is skewed right, it really drags the mean to the right, not so much with the median. The median tends to remain more constant than the mean does, okay? And then the data, we would predict it to be skewed to the left if the mean is less than the median. Okay, because again, if the mean is further to the left, further to the left than the median, then the data is probably skewed to the left, which is why the mean is so far out of whack. Okay. And again, these are only possible predictions. They're not always going to be 100% accurate. When we look at the graph, we might make a different judgment call, okay? And so these are just ways of predicting without having to draw an entire graph, okay? And so again, when we look at this data, I'm going to find the measures of center, and then we're going to predict to see if we think this thing would be skewed right, skewed left, or symmetrical, okay? And so looking at this data, once again, I'm going to find the mean. So my sample mean equals. Again, I have to go over here and I have to add up all these data values together. What we're actually going to do this time is I'm going to show you, rather than doing this by hand, I'm going to show you how we can calculate the mean using Google Sheets. Okay, so I'm going to jump over to Google Sheets here. So over here in Google Sheets, I've already taken the liberty of punching the data in. You'll have to do that either manually or copy and paste, depending on the formatting that you get the data in originally. But we type these things in, and what's nice is in Google Sheets, like even if these were out of order, I can click this little drop-down menu and say sort A to Z, and it'll rearrange them into the proper order for me if they're out of order. The other nice thing here is you can kind of look along the side here, and it counts how many data values you have, so you can see that it's 20. And so now if I want to calculate the mean this time, what I'm going to do is I'm just going to highlight the data. Okay, so I highlight all the cells that have my data in it. And I go up here, and you might have to hit the 3 little dots to see this, but it looks like the sum symbol. That will not calculate the sum. That gives us all the calculations. They just randomly chose that symbol in Google Sheets. But if you click on that, it gives me all kinds of things that I can calculate. And one of the ones right here is average. You can click on it right there. There's also more options in the statistics menu down here, and you could go to the average from there as well, average, okay? They don't officially call it the mean, even though the mean and the average are the same thing. So you click on average, and notice it went to, sorry, you can't see it here, but it pasted it down here in the next available cell. And so it gave me 115.9. So that's my my average. You could also calculate the median by highlighting the data and then going up here. And this time it's not located there. You have to go into the statistics menu and you have to scroll down to median, and it will allow you to calculate that. I went right past it. Median right here. Okay. The only thing is you'll have to select a different cell or it's going to delete your mean. The other thing is, when I'm personally doing the median, I don't bother with this because I can see right here there's 20 data values, which really means that my median will be somewhere right here between the 10th and the 11th data value. If I go halfway in between there, I can see that it's 108.5. Okay. So again, calculating the mean will do that for us, but we can just look at it and get it from the list as well. So now that I've got those, let me go back over to my data set and write those down. And so for this, we calculated the mean here is 115.9. We calculated the median as 108.5. And so when we look at this, I can see that the mean looks significantly bigger than the median. I wouldn't say they're pretty much the same. So because the mean is bigger than the mean is farther to the right than the median, I'm going to predict that this data is going to be skewed to the right. And really the only way to confirm that is to go ahead and graph this thing. So we'll do this graph this time. But again, in the future, this will help us identify the shape without actually having to draw a graph of this thing. Okay. And so for this one, let's just draw a quick histogram here. And though histograms aren't always exactly quick, we'll do a quick histogram here. The height and the frequency. Let's see. I'm just going to go by 20, so I'm going to do 70 to 90. Uh, 150 to 170. And I need one more. And if I start counting up the frequencies here, 70 to 90 looks like I've got 5 of them. 90 to 110 looks like I have 6. 110 to 130 is 3. And again, make sure you're only counting the overlaps with the second of these things. The 130 would count in the second time that appears. That's 110 to less than 130. Again, it's one of those easy common mistakes that students make. There's a 4 here and then 1 here. Okay. So down here, again, we do it like a number line, 70, 90, 110, 130, 150, 170, and 190. And up here, I can count by ones again. And so this first group has a height of 5. The next group had a height of 6. 3, 1, 4, and 1. Again, let me do some little quick shading versions of this thing. Just because visually it makes it a lot easier to look at, a lot easier to discern certain things. And so when we look at this thing, if I were to kind of talk about the shape, outlier, center, of spreads of the thing, if I describe the data, I can clearly see that this data does look skewed to the right. Okay, so if I was describing the shape of this thing, I might say, hey, this thing is, I might say it's bimodal. I might say it's bimodal as well, but it's also clearly skewed to the right. So skewed to the right, it doesn't appear to be any outliers. The center is around 109, which is also kind of confirming our median. And the data goes from around 70 to around 190. Okay. And so again, this was a great predictor of the shape now that we've drawn this thing. Okay. So the mean, again, the mean, we add them all together, divide by how many we have. Google Sheets can calculate that for us. And again, the mean is best when we're talking about symmetrical or only slightly skewed data. The median is that middle data value. And we use that when the data is clearly skewed or sometimes when there are very big or very small outliers. Okay.